There's one final way that we will solve systems of equations, but we won't look at that until the next lesson. Systems are important because they tell us multiple conditions that relate multiple variables or unknowns. In this lesson, we're going to experiment with systems and what we can do with them and how this affects their solutions. So look at exercise number 1. Consider this system on the right and that the solution to that system is 1, 5. Show that x equals 1 and y equals 5 is the solution to the systems of equations. So we're simply going to do what we've done in the past. We're going to plug 1 in for every x and 5 in for every y to see if both of the equations are true. So the first equation, 4 times 1 plus 2 times 5, does it equal 14? 4 plus 10, does it equal 14? Yeah, 4 plus 10 equals 14. Then the second one is 1 minus 5 equal to negative 4. Yes, negative 4 is equal to negative 4, so that's how it's true. Then it says, find the sum of the two equations. Is the point 1, 5 a solution to this new equation? Justify your yes or no response. So what this looks like is we're going to take both the equations. So 4x plus 2y equals 14, and 1x minus 1y equals negative 4. And we're going to make this a giant addition problem. So 5x plus 1y, does it equal 10? So now we're going to plug in 1 for x and 5 for y and see if it's true. So 5 times 1 plus 1, sorry, I did that wrong. Nope, I did that right. Plus 1 times 5, does it equal 10? Well, 5 plus 5, does that equal 10? Yes, it does. Letter C says to multiply both sides of the second equation by 2 to get an equivalent equation. So our original equation is x minus y equals negative 4. But what it's asking us to do is multiply this by 2. So 2 times x is 2x minus 2 times y is 2y equals 2 times negative 4 is negative 8. So now we're going to plug those numbers back in. So 2 times 1 minus 2 times 5, does it equal negative 8? 2 minus 10, does that equal negative 8? Yes, it does. Then we're going to take the equation we found in C and add it to the first equation. What happens? So our first equation again is 4x plus 2y equals 14. And the new equation we came up with in letter C was 2x minus 2y equals negative 8. It's asking us what happens if we now add these together. Well, 4x plus 2x is 6x, but you'll notice that we have positive 2y minus 2y, so they actually cancel out or they eliminate. This equals 6. If I solve for x equals 1, right? Because 6 divided by 6 is 1. Once we know the value of x, how can we find the value of y? Well, we can plug it back into the original equation of 4x plus 2y equals 14, but now we know that it's 4 times 1 plus 2y equals 14. So 4 plus 2y equals 14. Subtract 4 from each side. 2y equals 10. Divide by 2, and y equals 5. So what we see is that a solution to a system of equations remains a solution to that system under a variety of conditions. Solutions to systems remain solutions if the properties of equality are used to rewrite either of the equations, the equations are added or subtracted, or any rewrite is added or subtracted. So let's play with some more of these ideas, but with a new system of equations. So consider this system shown to the right. Show that the point 3, negative 1 is the solution. So we're going to do just what we did before. So 4 times 3 minus 3 times negative 1 is equal to 15. And 3 times 3 plus 2 times negative 1 equals 7. So the first equation, 12 plus 3 equals 15. So 15 equals 15. So my first equation is true. 9 minus 2 equals 7. So 7 equals 7. So my second equation is true. The point 3, negative 1 will be a solution to this system shown below. But how can you determine this without substituting the point in? We're going to look at the equations we had up above. In this first equation, what happens to go from 4x minus 3y equals 15 to 8x minus 6y equals 30? Well, hopefully you see that that first one, to go from 4x minus 3y equals 15, that you actually multiplied by 2 to get to your new equation. And then our second one, to get from 3x plus 2y equals 7, to go from here to here, you multiplied by 3. So to show that, the first one, 4x minus 3y equals 15, if I multiply that by 2, I get 8x minus 6y equals 30. In the second equation, 3x plus 2y equals 7. If I multiply everything by 3, I get 9x plus 6y equals 21. So what happens when you add these two equations together? So I have 8x plus 6y equals 30, and I have 9x plus 6y equals 21. Sorry, this is a minus 6y. I wrote that as a plus, but it's definitely a minus. So now if we combine these, I have 17x, and I have negative 6y and positive 6y, so they cancel each other out, equals 51. We divide both sides by 17, and x equals 3. So what we did is we eliminated the y. Now we can take what we found for x and find y. Pick one of the equations. So if we did 8 times 3 minus 6y equals 30, I now have 24 minus 6y equals 30. Subtract 24. Negative 6y equals 6. Divide by negative 6. And y equals negative 1. One thing I didn't show you before is that anytime you find an x and a y, you always need to write them as an ordered pair. Now we're going to solve this system below using the method of elimination that we've worked through. Show the steps in your work and show your answer is in fact a solution to the system. So what we need to do is we need to get one of these to end up being the same number but opposite. So if I want to get rid of the x's, I want them to be the same number. Well, I know I can multiply 2 by 3 to get 6x, but in order to eliminate, I have to actually make it a negative 6. So that becomes negative 6x minus 12y equals negative 6. Notice that I distributed that negative 3 to all three parts. I'm going to rewrite the second equation. So 6x plus 3y equals negative 3. And we're going to combine everything. The x's eliminate. I get negative 9y equals negative 9. Divide both sides by negative 9, and y equals 1. So this is our first part of our coordinate point. Now we're going to pick one of the original equations. So if I do 6x plus 3 times 1 equals negative 3. So 6x plus 3 equals negative 3. And we're going to subtract 3 from both sides. 6x equals negative 6. Divide by 6, and x equals negative 1. If I wanted to show that it is in fact a solution to the system, I could then plug -1 in for the x on both of them, and I could plug 1 in for the y on both of them, and show that they are both true.